So Eric Van Dusen is the Technology and Outreach Lead for Data Science Undergraduate Studies at UC Berkeley, where he's pushing for applying open science tools to undergraduate social science instruction. And that's exactly what he's going to talk about here today. Eric, the floor is yours.
Thanks, everybody. As far as my job title goes, I'm also a lecturer at UC Berkeley, which is a confusing thing where you have to have an academic and a staff appointment, but I'm dancing between those two worlds. What I want to start with is just sort of planting the topic with the new idea that I'm learning from the education field, metacognition. Do you think about the process of learning? So metacognition here would be like, if we're teaching students in Jupyter notebooks or RStudio or our Markdown things, our Markdown notebooks, are the students thinking about the process that they're in? What I'm going to propose is that we have a whole set of tools that are built for reproducibility that are very powerful tools for pedagogy. And the curriculum that we're working with is built on this whole set of open source tools. Students are explicitly learning the new reproducible toolkits, but they're also learning implicitly about this workflow and the way their classes are delivered. The first year students are learning Jupyter and NumPy, but they're learning a tool that will scaffold them and give them ability to do more over time. The people teaching and deploying the classes are learning GitHub, open publishing. They're learning those elements while they teach the class. Finally, there's something about data science where we're simultaneously teaching computational thinking and inferential thinking. It's not just the economists can just do hypothesis test and regression. They need to learn some code as well. The computer science and the machine learning students need to learn inference. If we just let machine learning be run by the computer scientists, where are what we as social scientists and statisticians can contribute to thinking about inference? Overarching theme here is we're starting to teach in notebooks. And is this an evolution? What elements are this of an evolution in the way that we're teaching? So I'm going to start with one thing that I do is I represent what's called the Berkeley Data Science Teaching Stack. I represent it within UC Berkeley and exterior to UC Berkeley. And I'm going to say it's not one single tool. It's a whole set of open source tools originally built around this fundamentals class, Data 8. One reason they built it that way was for inclusion and accessibility. Any student on any laptop can run the homework exactly the same, right? So if we get back to like across platforms, the same outcome will come out of your homework. That's related to our idea of our journal articles working when they're reproduced later. Also, anyone can teach it. So we can port this curriculum from within UC Berkeley to universities around the world. It's also built to be scalable. There's a lot about the tools of open science that make it so that you can scale things up. So they went from teaching a 100-person class to a 1,500-person class, but keeping this active learning in place. And from there, we've expanded into a lot of other fields. And now I'll talk about this, connector classes and modules classes. So not just the data science classes, but all sorts of other classes. Finally, I would say I'm learning a ton from the people that are the infrastructure people that are building this server. So there's a server that underlays everyone in UC Berkeley's access called the Berkeley Data Hub, or it's a Jupyter Hub. But the way they deploy things with continuous integration, with like adherence to a radical openness, I'm learning a lot from the way the infrastructure is deployed, about practices of open source, community building that I think is really infecting the teaching. If you're in Data 8 or Data 100, you have a free textbook. You have an open source software stack on every single homework you do. You have all of the curriculum is open source as well. The server, the textbook, the packages, the autograder, the homeworks, those are all in public GitHub repos. If you come to check out Data 8 from another university, you can see every single element of the stack documented in GitHub. You can take it, you can fork it. So these tools can be used for any type of class, not just for Data 8. And I'll also say the mantra from the infrastructure side is let's put guardrails, not gates. Let's make it so that anybody can use it, a safe, small amount of compute anywhere across the university. So on my staff job, what I do is I promote these data science tools to other sorts of classes. And I go out to instructors and I say, hey, you could teach with notebooks. Let's translate your homework. Let's translate your lab assignment. Let's give students a little bit of data science while they're in that biology class or their city planning class, and give them a little bit of their tools. So we've been collaborating across campus for several years. We've served over 13,000 students in 80 different classes. And we have a student team that builds these notebooks for the other faculty. So in a lot of cases, the faculty don't do the programming. We have the data science students come in and do the programming with them and build notebooks for other classes. We have environmental justice, social justice. And one thing that we believe, if these Jupyter notebooks can succeed, we're making data science accessible to a broader base of students. So on the topic of this conference, what are some of the open science tools that students learn by working in notebooks? The students learn some elements of coding along with some elements of statistics, right? So the coding and learning about the packages is going to broaden their horizon of what they're going to learn. They're going to learn to work in literate code documents. This is a lot of what we're promoting in reproducibility. If you're going to submit a journal article, submit some literate code that explains what you do. If students are learning this way, it's going to be a first practice that they're going to learn. The next is this consistent environments. If we build it so that the class can be taught and you could do the homework on an iPad or a Mac, a Chromebook. I have sat in the class. I've seen the students open their homeworks on their phones. Like, if we can build a computational environment that works across platforms and students work in that for equity angle, there's also going to be a reproducibility angle. If we build the courses on GitHub and the student course staff knows how to post the homeworks and how to get the homeworks from GitHub, they're learning some of those steps. Even if in an elemental place, they're being exposed to these tools. If we're making the curriculum transparent to the students, they're going to learn that over time. Another thing is, like, how we're teaching here is different. Instead of the parametric approaches that are starting with a pencil and an equation, we're starting with data. Instead of like getting, how are we going to do inference based on, based on an equation, we're resampling or bootstrapping first. And we're also having students work on projects first. So if you do data 8 or data 100, you do long, complicated projects, but those aren't that far away from what we're talking about for, reproducing, a project that would be a publication. Finally, if the instructors are working in notebooks, you can really easily stitch those into open education resource textbooks. So if you look at the data 8 and data 100 textbooks that are free and open, the instructors are teaching in the reproducible notebooks. They can command line, make their lecture notes real time, stitch them into a textbook. So there's no Stata-based textbook, right? There's no person who's like run a command line on their Stata files and made a textbook. This is becoming common practice in R and Python. Finally, this is a little bit subtle, but the students in these classes go through, and there's auto graders embedded in the homeworks and labs. Auto grading is like a form of software testing, and it's taken from the software testing world. So if we go back to Lars's talk from this morning, we have students seeing this little bit of software testing as they do their very first homework. And when the instructor needs to submit the homeworks to be graded on Gradescope, they're using a Docker to do this. So the instructors are also learning Docker as they build and deploy the homeworks. So I built this slide, and I don't want to take credit for this, but I want to say I was here at UC Berkeley when this happened, right? So
sorry, I'm not on mute.
That was awesome. That was like my emphasis slide here. Right?
That was totally planned. You're welcome.
So we have replaced Stata, and we have deployed notebook-based instruction in the core methods courses of the main social science class, some of the main social science classes, not exclusively all of them, but almost all of them in the last 3 or 4 years, right? This is a revolution. It's happening. If we make the freshmen learn this way, think when they're PhD students. We won't have to worry about Stata because it won't be their default language. But let me go on. All of these notebooks are in the public domain on a repo, mostly hosted by us, github.com DS modules, but maybe in the instructors as well. As you can see in a few of these, notably in environmental economics, in public health, the curriculum materials are passed from instructor to instructor, term to term. Why is this awesome? Because it's a consistent outcome for their program that they have consistent learning outcomes, and with reproducible homeworks, you can make sure they're consistent. But it's also showing like this workflow based on making things pass between researchers also makes it so you can pass things between teachers. So in the middle here, and I'll get back to these, Econ 140, Environmental Economics 118, UGBA 88. This is the core class of people learning econometrics at UC Berkeley, all in notebooks, all in the past few semesters, but we got repeat semesters right now. So, some of these are rough, some of these are smooth, some of these are like continuously deployed, some of these are keep evolving. But I would say, this is 2,000 students per semester. Every student in all of these majors, psychology is not on here. It's taught in R as well. There's more majors that aren't even on this list. These are the ones that I've participated with. Sometimes we help build the notebooks for them. Sometimes I'm just there to meet with the instructor, show them how the platform works, show them how to use GitHub to deploy their class. Sometimes the instructor is ready to go, and I'm just like facilitating them doing the work. So this is sort of, a slide that I just made for this talk, but I'm going to say this is sort of my life work over the past few years. And for me, making the slide made me realize, where we are. For an example, I can show you some political science. So every political science student has to take poli-sci 3. A lot of times they hate it. A lot of times poli-sci kids didn't look forward to doing quantitative methods, and they have to take this class. Same goes for the econometrics class. So we have been bringing notebooks in now little by little, replacing a slide of Stata. It was too hard to get everyone in the class licensed with Stata, so the instructor was showing slides of Stata. Now we can deploy these notebooks where students can touch things. They can, have examples that are relevant to political science at their fingers while they're doing a homework. The most recent iteration is with the younger professor, David Brookman, who is just an amazing person, a famous role in the reproducibility crisis. Google David Brookman, and it's totally entertaining. There's like a This American Life and stuff. He fully internalizes this. And he is deploying this in a flipped classroom in his class with the autograder. First 10 minutes of class, mini notebook. Students try 2 lines of code. If they get it, the autograder tells them they're right. Then he goes and teaches class. So this is an advanced deployment where the instructor has really internalized the flow of reproducibility and is using that constantly every single day in their class. The class has like 20 or 30 notebooks. From every single class meeting, you just touch the data a little bit, you learn 1 or 2 lines of code. And he has turned around poli-sci 3. It's getting better reviews than it's ever gotten. And students are like, I didn't think I could code, but now I know I can, right? This is the thing we're looking for, is empowering people as well. Can notebook-based instructions make people, the drudgery of doing quantitative work, make it feel like more empowering to them? And, this is Jupyter R, a platform that I like, where it's nested, is this a textbook? Is this lecture notes? This is a live document where the instructor is explaining omitted variable bias or causation, and there's a single line of code that executes. So we're breaking down the wall, like the textbook's over here, the compute's over here. With these documents, we're breaking down this wall so that the students can be learning, coding, displaying, seeing output all at the same time. So what about economics and data science? This is another part of my past few years' work. It's just collecting these quotes and working with influential people in the field. David Card came to my last day of class. He says, econometrics could use a lot of the techniques coming from data science. Tom Sargent, we had a workshop on economics and data science last year. He says, I write Jupyter notebooks, I write Python, I try out my models in Python. I think the students in Berkeley today are lucky. Brad DeLong is somebody who started teaching with Jupyter notebooks several years ago before I came into the position. He has this great quote that he says, data science tools are the fine chancery hand that a student needed to know in the 1400s. It's their practical general skills that will make you of value to any job you go to. Finally, a little bit more provocative is Stephen Levitt, who says, people are in economics because it's a quantitative major. If economics doesn't evolve, if economics continues to be the major it is now, and data science emerges as an alternative, a good chunk of people currently in economics will realize it makes more sense to be a data science major. I think that's a pretty provocative quote. And in a lot of ways, that's why I'm really interested in this space and how can we evolve economics to bring in the data science tools. So where are we? Where are we with undergraduate education today? So here are the top top 6 undergraduate majors at UC Berkeley. Computer science, sorry, if you can't read this, top line is computer science, who has displaced economics as the top major at UC Berkeley. Second top major is economics, 760 students. Out of nowhere, the data science major appears and rockets to third place, just next to economics. The fourth top major is computer science in the College of Engineering, which here we call EECS. So computer science has really broken the university. Fifth is political science, and sixth is business administration. So this cluster of coding, data science, and economics is the top thing at the top public university in the country, right? There's a lot going on here. I work for the data science major. This thing that just appeared and is now in third place. So within the data science major, you need to declare a domain emphasis, right? You need to take 2 advanced classes in a field. 26% of the students are in business or industrial analytics, and another 20% of the students are in econ. So of the 1,000 students in this new major, 45% of them are doing something econ or business optimization. This is a huge number here. Quantitative social science, 6th biggest as well. Finally, what about double majors? So of the people majoring in data science, the number 1 double major is economics, right? So there's 188 double majors between data science and economics. That's more than there are stats majors or history majors. If you combine economics and business administration as double majors, you're almost to the number of English majors. This is a disruption. This is a moment of disruption in the university. I will add, as a caveat, there are no data science professors. There are professors taken from CS and stats, but there's a lot of professors in history and English. So econometrics, right? The core class, everyone has to take it. Every single one of the majors has to take it. We are in the 4th semester post-STATA for Econ 140. It's a big class, 450 people. It'll probably in R this summer and next year. It's been taught one time in R in the past as well. And the notebooks for this class, there's 5 homeworks for the class. They were built by an undergrad double major who is a GSI for Econ 140. So I want you to believe that the students are making the curriculum materials that are changing the university. Environmental Economics 118. This is probably my most successful one. I didn't do this. There was a grad student who was teaching Econ 118 over the summer. had everything in R Markdown because that's how they think and work, was able to build all of the homeworks for the class as a matter of course of teaching the class. And this class has been taught for 6 semesters in Jupyter R, handed off from faculty member to faculty member, and pretty successful and pretty well liked and a successful deployment for the students. Different approaches here. So there's a lot of pedagogical choices. How much do you pre-code for the students? Do you read the data set in for the students, or you get the students to find the data set and read them in themselves? So a lot of people with a lot of choices of how things need to be deployed. But it's a framework, it's a platform. So here's my class. So I teach what's called a data science connector class. The idea for the connector class is, before I got to the program, was that you could teach data 8 to 1,500 people, but that it'd be interesting to teach in a domain how they could apply data 8 tools. I first got hired and I taught a class based on working with Ted Miguel, based on a data set that I had from working with IPA in Kenya. Then I taught a class specifically on reproducibility to data 8 undergrads. But then I met the students and they were excited about this project of what were the overlaps between econ and data science. And I worked with the students to build this class. We're in our 6th semester. We started with 25 students. We're now up to 100 students. And it's what would it be like to teach economics through Jupyter Notebooks all the way through. We start out Econ 1, Econ 100, we get to development, we get to labor, we get to inequality later on. The idea is like, what if we're teaching econ all the way through Python? And what if we're teaching the economic students, a whole bunch of Python tools, a whole assortment of different Python tools that would be useful to them later on? I have an idea for a proposed class that I'm building a syllabus for right now that would be an upper division class. And this was a little bit prompted by David Card coming to our class. And, the idea is like, what are the skills of data science that a great undergrad would need that aren't taught in econometrics? Econometrics is a lot about regression analysis, and there's a lot to get through in a semester of regression analysis. But you're handed a clean and tidy data set every time in econometrics class. And David Card comes to class and he's like, no, it's the building the data set. That's the work. That's a whole bunch of the time. That's what it's like to be a researcher. What's it like to go to the API and pull the data out of that? How do our undergrads get that experience? The data cleaning, the merging. What if you lose half your observations when you do a merge or a join? No one ever tells you how to do that. So some of it could be prompted by David Card likes amazing data science RAs to work with him. What's it like to give those students those tools to be the amazing RAs? We also don't teach data visualization in econometrics. And this is sort of amazing because data visualization, is sort of a base thing that journal articles have, but we've never really taught it. Finally, as it's my passion as a member of this community, what are the elements of reproducibility and reproducible practices that would be embedded into an undergraduate class? So how can we teach undergrads about data practices that would include reproducibility early on? One other thing I want to do is give a shout out to other people in the field that I see as people doing it well, better than me, bigger profile projects. One is the Harvard Big Data class. Right. So this class is by Raj Chetty, has these big data, projects that are available. They don't teach in notebooks, but all the slides, PowerPoints, lecture notes, and the background for the projects is all posted. A lot of stuff about inequality, a lot of policy relevant work that Raj Chetty's putting out, translated into student projects using big data. So I really see this as like a premier place at Harvard, obviously a super premier high visibility class that's, starting to move in this work. And we've worked with them a little bit, trying to see if we could make notebooks that follow along their curriculum. The other legends, titans in the field are QuantEcon. They have taken this all to heart, like lecture notes, textbooks, materials. Like they have like whole curriculum that you could take, and there's a community of sort of teacher researchers there. But they have the whole workflow of like contributing to the Python package, how to build the textbook, how to share the materials. So to wrap up, finally, what do we do to get what we've done for open science working for open curriculum? So economists post their working papers, they're posting their data sets. That's what this conference is about. People don't post their syllabuses. People don't post their lecture notes necessarily. People rarely post their homeworks. And this is what I work with is like the homeworks and projects are sort of the meat of the curriculum. Most classes at most universities are behind an LMS wall. So how do we incentivize people to put their syllabi in the public domain? I did a non-scientific sample here. Ted Miguel's syllabuses are online. David Card, a few of them from 2015, but not in a systematic way necessarily. Are your lecture notes online? Ted Miguel's lecture notes aren't online. They are for bits, but they aren't necessarily for Econ 172. David Card, some of them are for some of his for his graduate classes. Are any of are Ted or David's homeworks online? Not necessarily. So, not that they need to, but like, what do we do to change this culture moving forward? Learn from David Brookman, learn from Raj Chetty about how to put this together. So I want to wrap up, and I want to thank the students that I work with who do so much of the work here. They had the vision for the class. I collaborated with them. They're still creating materials. They're still teaching the class with me. The class that I teach next year, that will be on, practices, data science practices economists should know, will totally be built again in collaboration with the students who are doing this work, serving as the RAs, doing social science reproducibility platform. It's the students who can see this future, and they're building the curriculum.
Thank you so much, Eric. It sounds like there's a revolution in how we teach economics, social sciences going on at the university, and you're at the forefront of it. So this was so exciting to learn about.